Hello, everybody. So, hello, everybody. I'm Denis Nuja, technical resource from Croit. Croit is a company that creates management framework around open source projects, historically around SEP, and today around DAOs. So, this is going to be a little technical discussion about how we implemented SPDK DAOS device or DAOS, which allowed us to create an MVM over time. So, DAOS provides some basic interfaces for API with views, but no other, if you want to call them traditional storage access methods like NFS, block, etc. So at Croit, we have decided to actually implement those. The first one that will be released is the fabric, and the second one will be NFS. So if you want block, NVMe or fabric is currently the choice of technology to use. And the clients are already included in most of the operating systems out there. So if you want to use Windows, or VMware, or anything, it's already there. We decided to use SPDK for target for the simple reason that out of box, it supports pretty much everything you would want out of that target. So, plus it also supports storage does. But the most important thing is it supports multi-path, it supports stacking, so we can actually stack logical volumes, bigger volumes, and rate calculations and everything. Plus, it also supports a lot of the tooling around it, so we can actually inspect how it's performing, what's happening in the Substack, and test and everything. So out of the box, it's a very good solution for it, and it was the only logical solution for this, because the other ones are mostly code-based. As we know, Deus is a user space. How did we do this? It was actually very easy. SPDK supports some predefined bit of implementations. Mongo and AIO are open source, they're free. And we had a look, and it didn't look complicated at all. So what we did is we take the AIO beta and we just ripped out the source code for the backend and replaced it with DAOS functions. What happened is it worked out of the box. These are some of the minimum operationalists required to actually do this. So read, write, reset, flush, and the only one that we didn't implement is the reset, because there's no real functionality towards this. We could use that. So the current implementation, we just wait for all the requests to finish, and the rest is how to say it. Then the decision was what kind of DAOS API to actually use. If using Array versus DFS, what we found is that they're pretty similar, actually very much the same. But the DFS one proved to be a better choice because it allows us also to do some additional management and abuse externally. In this case, the virtual disk that is basically exposed as a maybe a target ends up being a file on the DFS. We can access that file directly. We can copy it somewhere, we can clone it, replicate, whatever we really want. So from an operational standpoint, it was a better choice. The initial version of the implementation was that every device channel has its own polar, and then behind that polar is DAOS bdev. We tested this. It had pretty linear scale, so more channels, more polars, more performance, eventually up to the limits of the cluster. this kind of how it looks based on cores, mapping the cores to the SPDKs for bdevs. Bdevs are basically virtual disks on the these are the results of the initial implementation, which for us proved to be very interesting. If we look at 7 millisecond latency, we're pushing about 1.25 million items from a single client. By the way, this is a non-RDMA cluster on pure Ethernet. So this is a limitation of our current test cluster, which is using E810 Colombian mix. So only 3 DAOS nodes were involved in this, and a single client on the bench. So as you can see, even on that kind of a setup, the performance was actually very good. We are currently in the process of deploying a secondary test bench, which is going to be on Mellanox Ethernet and InfiniBand. So we'll soon have numbers to compare how it looks across the different access methods. Some of the pitfalls that we found across the way is that prior to DAOS 2.2, there were some issues with thread pool and container cache. This effectively limited the performance of multi-threaded access from a single device, but it scaled if you have multiple devices across the cluster. This was actually fixed in 2.2, and there's a ticket here if you want to read a little bit more about it on the Jira. All development that we do publicly, and you can find all of our findings and problems in the DAOS Jira. The biggest problem here is the MXM rules. So we have M devices that create M channels and embed queues. And what we found out is that actually the total amount is limited and fixed depending on the fabric provider. It's something that we cannot expand as it is now in this type of operation. So, for instance, on a TCP provider, you can have 256 queues. So, in theory, you can have 8 bdev with 32 cores attached to it, and you're involved with the queues. Also, the other pitfall is there's no way to actually reserve physical space inside a container and to know how much it's used. So, if you have a customer that starts just deploying bdevs crazy, at one point you will run out of space and you'll just get no space error. There's no way to actually see that more clearly. The next iteration, which is currently being done, is that we have a fixed pool of DAOS queues and a fixed pool of cores, and then we can dynamically assign across the bdevs. Also, what's being worked on is better recovery procedures. Because in most cases, SPDK will say, well, if I cannot write now, I can probably write in a little bit, and we'll keep trying. And yeah, there's no clear area. And also some additional quality of life improvements, like dealing with virtual loopholes, logic modems, which allows to do snapshots and clones, etc. Some of the acknowledgements, the whole SPDK community has been very welcoming to this, especially James Harris. He helped a lot with how to make things better. And of course, the DAOS team. John and Bannett have been a great asset and helped fix quite a lot of issues that we found. And this is actually how we use this in the Croit platform. So we have a generalized NVMe gateway across the platform, and we can map it to any type of backend storage. In this case, mostly DAOS, with some IOPS notation, relative service, provisioning, etc. That's pretty much it. I'll take any questions. So, go ahead.
Do you know how much CPU load this causes on your client versus setting up their
So the question is, how much CPU load is on the client itself? But actually, it's
On the client side, it's very minimal.
on the client side, it's very minimal. The CPU load happens from the everywhere recovery target. And there we can saturate very easily 64 cores in a machine when we're running very high loads. Yeah.
I saw you mentioned the AIO.
Yeah.
Does it have anything to do with the Linux AIO at all?
Oh, no. So,
Oh, okay, that's good
just
enough.
one AIO backend
Yeah,
SPDK.
that's
Let me
good.
check for
Linux AIO is terrible.
Any other questions? So if anybody's interested in this, the bdev implementation is open source and it's upstreamed into mainline SPDK code. So you can play with it from there. Thank you very much for this.